Hi, my name is Fatima Rajoush and I'm a clinical laboratory major at Wayne State University. In this speech, I'll be discussing the depletion of the Earth's ozone layer. Firstly, I would like to analyze some common products that contain a common chemical, which is the main cause of ozone depletion, and that is a chemical known as a chlorofluorocarbon, or a CFC, as abbreviated. And these are found in products such as Windex and aerosol cans. First, I would like to analyze the general information about the ozone layer, which will help me lead into the common causes and effects of ozone depletion. The ozone layer is located in the stratosphere, which is the layer that's second closest to the Earth's surface from the atmosphere. It contains molecules called ozone, which are three oxygen atoms bonded by a double bond and a single bond. And the main function of these molecules, or the layer in general, is to block or shield the Earth's surface from harmful ultraviolet radiation from the sun. And we know that the rate of production or formation or synthesis and the rate of decomposition is at equilibrium of this molecule, but the fluctuations shown later show otherwise. And the concentration of ozone is highest between 19 to 23 kilometers above the Earth's surface, but we know that this varies from altitude and season. One thing that caused the main concern about ozone depletion is the Antarctic ozone hole, which was discovered in 1985. This was recorded in a thesis paper by Ravan Shankara, in which he discussed that total global ozone declined by 5% since 1980s, and it remained constant beforehand, and that's what shocked many scientists. And so the ozone depletion became a real issue at that point. And with this, I would like to analyze some common trends in ozone concentration. As you could see, it's a little linear at first, not exactly linear, but they're kind of not decreasing or increasing very drastically, same as this graph. These are both graphs pulled off the internet from the Scottish Government and the European Environment Agency by Ortiz. And so around 2002 and through 2008, we see a drastic increase and decrease. And at these points, certain protocols were introduced in order to increase the ozone concentration again. And so with this, we know that there are some causes of the ozone depletion. And three causes were summarized by Anwar in his journal about ozone depletion causes. And those were chlorofluorocarbons, which are chemicals that contain all carbon, chlorine, and fluorine molecules. Rocket launches, which I will not discuss in much detail because they're not very important causes. And the nitrogenous compounds, which are such as nitrogen oxide, dinitrogen monoxide, and nitrate, nitrite, and so on and so forth. But I would like to analyze the main cause because that is what really causes the ozone depletion, and that is the chlorofluorocarbons. Chlorofluorocarbons are the ones that deplete the ozone molecules. They're highly volatile, meaning they are able to be evaporated really quickly, and they reach the stratosphere quickly. And that is where they get into contact with the ozone molecules. And this is a process called photolysis, in which the breakdown of ozone occurs. I will analyze it better in more detail in the next slide. And we know that chlorofluorocarbons are released in products such as refrigerants, aerosol cans, solvents, such as that I've described earlier. And so this is the process in which ozone is deteriorated. And so ultraviolet rays come from the sun, and the CFC releases a chlorine atom, and this chlorine atom interacts with the ozone molecule in a single displacement reaction in which one chlorine molecule bonds with one of the oxygens and takes it apart into a dioxygen molecule, or just natural oxygen. And the chlorine is recycled in a chain reaction, and it's redone until all of the ozone has been depleted. And that's what causes the ozone holes, which I will discuss as the effects of the ozone depletion. There are general effects, such as that it creates a general hole in the ozone layer. The ozone holes are commonly classified when the depletion level is under 200 Dobson units. And that is what the ozone hole is what causes the enhanced levels of ultraviolet radiation to reach the Earth's surface. And this radiation can cause increases in temperature and shifts in temperature structure. And according to Solomon, the southern hemisphere is what is heavily impacted by this, and mostly it's agriculture. This is not technically a negative impact, but this promotes plant hardiness and resistance to certain pesticides, and so plants can resist heat longer. And so I came up with some effects that are more specific to humans. And so the overexposure to UVB radiation or ultraviolet radiation can cause skin cancer, immunity suppression, damage to the lens and cornea, skin tanning, and vitamin D. These two last points are more positive effects because we know that the sun is the main source of vitamin D. So why is this relevant in any way possible? So we know that the primary effects of ozone depletion are that it technically affects the environment, but it also affects many factors such as politics, the economy, government, and society in general. And so impacts can be both positive and negative, as I discussed earlier. And this is a major topic in the field of atmospheric chemistry. And it's both caused by humans and natural occurrences. So I'm not going to blame it mostly on humans for the release of CFCs. And another thing is that it's interrelated to many other factors that affect us, such as sea surface temperatures, sea ice concentrations, and greenhouse gas concentrations, which are cited by Young in the American Geophysical Union. And so one common analogy I would like to leave you guys with is that the ozone acts as an umbrella.